Select the major product of the following Diels-Alder reactions. So whenever we're looking at a Diels-Alder reaction, we want to recognize the general mechanism, and it always involves the same 6 carbon atoms. It's going to involve the 4 carbon atoms of the diene and the 2 carbon atoms of your dienophile. And your dienophile could be an alkene as shown. As we'll see in this example, it can also be an alkyne. And so if we follow the arrows here, we can see that the only pi bond that remains is between carbons 2 and 3. So if I'm drawing the framework of the product where that alkene is carbons 2 and 3. And so then we can just continue numbering around the rest of the ring. And so if we're solving a Diels-Alder product, the best thing to do is to keep this numbering system. So I'm going to go to the diene and number carbons 1 through 4. And then to the dienophile and number carbons 5 and 6. And notice these are both symmetrical, so it doesn't matter where I start numbering, I'm going to get the same thing. And to draw the product then, I want to first draw these 6 carbon atoms. So I'm going to draw that cyclohexene structure with a pi bond between carbons 2 and 3. Okay, and then we are just going to inspect what we started with and see what was attached to each of those carbon atoms. And so if we look at the diene, the only thing besides those diene carbons we have is this CH2 group that's bridging carbons 1 and 4. So that means we've got to make a bridge of just 1 carbon atom between carbons 1 and 4. All right, so we definitely have a bridge structure. And then if we look at carbons 5 and 6, we started with an alkyne. And so this arrow right here tells us that we use 1 pi bond. So if we use 1 pi bond from the alkyne, that means there will still be a pi bond remaining, so it will be an alkene. And then we've got these 2 ketones that will still be attached. Being that this is an alkene, these are sp2 hybridized carbons, which means they are trigonal planar. So when I draw these bonds, I'm going to represent that trigonal planar geometry and add in these 2 ketones. And that's it. And if we inspect our options, we can see that this is A.